And now we talk about types of arrangement which the order was important in that case, or if we want to consider the order, so we use the permutation. But if selecting elements which order is not important, in this case, what should we do? In case of these types of selections which order is not important, we use combination. Or we can say that combination is an unordered selection of elements from a set. It can be all of them, or it can be some of these elements from the set. For example, if we want to choose or select a certain number of people from a group to form a committee, or if we want to make a football team from the students of the school. So in here the order is not important. In here the elements are important. For example, from 200 students in a school, from 200 students the total number is 200. We want to take 11 of them to make a football team. In this case we should use combination. In this case we said that a combination of 11 elements chosen from 200 elements. It means the total number of the set is 200 and we choose 11 of them. The order is not important. Or we can also say that the combination is also the OR element subsets of a set with n elements. Or and therefore for previous example 11 element subsets of a set which has 200 elements, and the total number of elements in the set is 200, but we want to find the 11 element subsets of these 200 elements. So we should also use a combination which we can show it by a combination of R chosen from n, or combination of R selected from n, which n and R, both of them are integers, and n is less than, n is greater than R, and R is between 0 and n. How can we calculate the number of combinations of R elements selected from n elements? Let's look at some examples. For example, this is a set K which is given for us 1, 2, 3. It has 3 elements. We want to find 2 element subsets of the K and 2 element permutations of the set K. For example, if we want to find 2 element subsets of them, so it can be 1, 2, 1, 3, and 2, 3. We have 3 different 2 element subsets, or 3 different combinations. But for each combination which it has 2 elements, we have 2 different or 2 factorial permutation. For example, 1, 2, and 2, 1. For 1, 3, 1, 3, and 3, 1. For 2 and 3, we have 2 and 2, 3, and 3, 2. So in here we have 3 combinations, but we have 6 permutations. Or in next example, this set A has 4 elements, but we want to find 3 element subsets for them. 3 element subsets means the combination of 3 elements which is chosen from these 4 elements, A, B, C, D. It can be A, B, C, A, B, D, A, C, D, and B, C, D. It means it has 4 combinations. But for each combination, which each of them has 3 elements, we have 3 factorial permutation. It means if for 4 elements, 3 element combination from 4 elements, we have 4 combinations, but we have 4 times 6, because for each combination we have 6, or 3 factorial permutation. So 24 permutations. Or we can say that there is a relation between them, between the permutation and the combination. What's that? It's look at this example. For example, in here, 3 factorial, because for each combination we have 3 in a factorial because it has 3 elements, times combination of 3 chosen from 4 is equal to permutation of 3 from these 4 elements. If we look at the previous example, or 2 element permutation for this example, so again we have a combination of 2 from 4. times, because for each combination we have 2 factorial permutations, so 2 factorial times combination of 2 from 4 is equal to permutation of 2 from 4, which is 4 factorial over 4 minus 2 factorial, which is 12. It means for a combination we have 6 elements, but each element has 2 factorial permutation. 6 times 2 factorial is equal to 12 elements permutation of them. Let's generalize it. So in this case, a combination of r chosen from n times r factorial, r is the number of elements which are chosen, is equal to permutation of r chosen from n. Or if we divide both sides by r factorial, so combination of r from n is equal to permutation of r from n over r factorial, or if we simplify them, we'll get n factorial over n minus 1 n minus r factorial times r factorial. This will be the number of combination which is the number of r element combination which are chosen from n elements. We can also show or denote combination of r elements selected from n elements by these ways. Combination of r chosen from n, n chooses r, or combination of r from n, and for by this notation and this notation we can show them, and it's read as n choose r. It means from n elements we select what? R elements, or the R element subset of a set with n elements. Let's solve some examples. Let's calculate a combination of 3 from 8. As we know that combination of r from n is n factorial over n minus r factorial times r factorial. So we apply the same rule by this example. So we say that combination of 3 from 8 is equal to 8 factorial over 8 minus 3 factorial times 3 factorial, which is equal to 8 times 7 times 6 times 5 factorial over 8 minus 3 is 5 factorial times 3 factorial. 5 factorial cancelled. 3 factorial is 6, so 3 factorial and 6 are cancelled. 8 times 7 is 56. So a combination of 3 from 8 is 56. How about the second example? Combination of 5 from 12 times combination of 2 from 7. Again, we do the same thing. Combination of 5 from 12 times combination of 7 from 2 from 7 is equal to 12 factorial over 12 minus 5 factorial times 5 factorial times 7 factorial over 7 minus 2 factorial times 2 factorial. If we calculate them, we will get 16,632. This is the calculation or evaluation of these two examples or these two combinations. Again, we have another example, combination of find the number of groups of 3 students which can be chosen from the class of 10 students. It means combination of 3 from 10. So we can calculate them. Combination of 3 from 10 is equal to 10 factorial over 10 minus 3 factorial times 3 factorial, which is equal to 10 times 9 times 8 times 7 factorial over 10 minus 3 is 7 factorial times 3 factorial. And 3 factorial is, let me write 3 factorial, 3 times 2 times 1. 7 factorial cancelled. 3 can be cancelled by 9 as 3, and 2 can be cancelled by 8 as 4. 3 times 4 is 12. 12 times 10 is 120. So we have 120 different groups of 3 students which can be chosen from these 10 students. The next example, there are 8 fruit pieces of different coins, including an apple on a tray. It means we have apple and seven different other piece of fruits, different fruits. I mean, how many selection of 4 pieces of fruit can we make if we have to include the apple? As in here we have a condition, we should include the apple. So from 4 pieces, one of them is gone. We have 3 different other choices. From these 7, because one of them was apple, so 7 fruit are left. So we should choose 3 of them. So again, combination of 3 from 7 is equal to 7 factorial over 7 minus 3 factorial times 3 factorial, and is equal to 7 times 6 times 5 times 4 factorial over 4 factorial times 3 factorial. 4 factorial, 4 factorial cancel, and 3 factorial is equal to 6. So 7 times 5 is 35. How many different choices do we have to select 4 pieces of fruit, which one of them is apple? From these 8 pieces of different fruits, there are 35 different choices. Another example, there are 10 players in a list. A basketball coach will choose 6 players from the list for a school team and make one of them the captain. In how many ways can the coach choose from or can make the team from this 10 players? So in here we have totally 10 players, and we want to select 6 of them. And among these 6, we should choose one of them as captain. So in here we have 2 different players. So one of them is a combination of 6 from 10. And also we should choose one of them as captain from these 6. So times combination of 1 from 6. If you multiply them, let's show them 10 factorial over 10 minus 6 factorial times 6 factorial, I'm sorry, times 6 factorial over 6 minus 1 factorial times 1 factorial, and it's equal to 10 times 9 times 8 times 7 times 6 factorial over 4 factorial times 6 factorial times 6 factorial, we can write as 6 times 5 factorial over 5 factorial times 1 factorial. 5 factorial, 5 factorial cancelled, 6 factorial and 6 factorial cancelled. 4 factorial is 24. We can write it as, or we can write it as 4 times 3 times 2 times 1. 3 times 2 and 6 are cancelled. So what's left in here? 4, 2. If we multiply them, we will get 1260 different selection or order or combination. I'm sorry, not order, combination from these 10 students or 10 players. He can choose 6 of them as a team, and he can choose from these 6 one as captain.